5.5 Lesson 1, the Mean Value Theorem and Rolle's Theorem. Our objectives are 1, you will understand the statement of Rolle's Theorem, and 2, you will understand the statement of the Mean Value Theorem. You see that we have some vocabulary here. When we're talking about a conditional statement, if P, then Q, what we have here, whatever we have there, that's called the hypothesis, and what we have here is called the conclusion of the conditional statement. What exactly does this conditional statement mean? It means that when these conditions are satisfied, it is sufficient for you to know that the conclusion must be true. The reason why we use the word sufficient is because if you have this, then this has to be true, but the hypotheses are not necessarily needed for Q to be true. But if you have them, you know that Q has to be true. That's why we say sufficient conditions. And then relating to these two theorems, we have these vocabulary terms that we've seen before: secant line, tangent line, average rate of change, instantaneous rate of change. So let's start with these problems here. Graph f of x is equal to sine x on the closed interval from 0 to pi. So here's the graph of f of x is equal to sine x, and we have the interval from 0 to pi here. Is there a horizontal tangent line to the graph of f at Is there a horizontal tangent line? Is there a horizontal tangent line to the graph of f of x is equal to sine x somewhere on the interval from 0 to pi? Let's think about that using Desmos, and then we'll come back to our discussion here. So as we saw with our Desmos demonstration, there is a horizontal tangent line to the graph of f of x is equal to sine x on the interval from x is equal to 0 and x is equal to pi. And that happens at x is equal to pi over 2. And here's the horizontal tangent line to the graph of f. Will this happen, and under what conditions will this happen? That's what Rolle's theorem is about. Rolle's theorem states that if you have a function that is differentiable for all values of x on the open interval from a to b, in our case that would be the open interval from 0 to pi, and because we can find the derivative of f, we know f prime of x is equal to the derivative of sine is cosine x, and this function is defined at all of these values. We know that our function f is differentiable for all values of x in the open interval from a to b, 0 to pi. And if we also know that the function f is continuous for all values of x in the closed interval from a to b, that would be the closed interval from 0 to pi, and we know that to be true because trig functions are continuous on their domains. And we also know that f of a is equal to 0 and f of b is equal to 0. And with us, that would be f of 0, sine of 0 is 0, and f of pi, sine of pi is also equal to 0. So if all three of these conditions are satisfied, if all these three conditions from the hypotheses of Rolle's theorem are satisfied, then that is sufficient for us to conclude that there must be at least one x value between a and b, between 0 and pi, such that f prime of c will be equal to 0. And that's what we saw with the Desmos. There is one x value between 0 and pi, specifically pi over 2, at which the tangent line will have a slope of 0, at which the tangent line will be horizontal. And Rolle's theorem is called an existence theorem. It tells you that there is at least one such value c between a and b, at which the tangent line will be horizontal. It doesn't tell you how to find that value. So if you wanted to find this value and you weren't using Desmos, how would you find it? Well, you would set the derivative of the function equal to 0 and solve for x, because the derivative of the function tells you slopes of tangent lines, and you want to know if there is an x value between 0 and pi at which the tangent line will have a slope of 0. So set f prime of x equal to 0 and solve for x. And there is an x value between 0 and pi at which cosine will be equal to 0, and that is, of course, pi over 2. So this is what Rolle's theorem states. So we've gone over objective 1. You will understand the statement of Rolle's theorem, and now we will take a look at our second start problem to help us understand the statement of the mean value theorem. Here's the second start problem. Graph f of x is equal to x squared on the closed interval from 0 to 2. And of course, you get this parabola. And part A says, find the slope of the secant line that passes through 0 f of 0 and 2 f of 2. Well, here is 0 f of 0, and here is 2 f of 2. And this is the graph of f. So to find the slope of that secant line, you need to use the formula for slope, which is the change in y divided by the change in x. So the y coordinate here at point B would be f of 2. The y coordinate at point A would be f of 1. The x coordinate at point B would be 2. And the x coordinate at point A would be 0. So the slope of the tangent of the secant line passing through points A and B would be f of 2 would be 2 squared. It's not f of 1, it's f of 0, because point A has coordinates 0, f of 0. F of 0 would be 0, and then 2 minus 0 is 2. So the slope of the secant line is 2. So we found the slope of the secant line passing through points A and B. It is 2. And I can go ahead and sketch that secant line passing through points A and B. And the question that we have is there a tangent line to the graph of f? Is there a tangent line to the parabola on the interval from 0 to 2 such that the tangent line is parallel to the secant line that we just sketched? Let's take a look at Desmos for that. As we just saw with our Desmos demonstration, there is a tangent line to the graph of f on the interval from 0 to 2 such that the tangent line will be parallel to the secant line that you see drawn in black. And we found using Desmos that that tangent line will be at x is equal to 1. So the slope of the tangent line at x is equal to 1 will also be 2, making that tangent line parallel to the secant line. So let's take a look at the mean value theorem. It states that if these two conditions are satisfied, then it is sufficient for us to know, based on these two conditions being satisfied, that this conclusion must follow. So if you know that the function f is differentiable for all values of x in the open interval from a to b, for us the open interval will be from 0 to 2, and do we know that this function f is differentiable for all values of x on the interval from 0 to 2, the derivative of the function is 2x, which is defined for all values of x on this interval. So this condition is satisfied from the two hypotheses of the mean value theorem. And if we know that the function f is continuous for all values of x in the closed interval from a to b, that would be the closed interval from 0 to 2 for us. And f of x is a polynomial function, which is continuous at all real numbers. So this condition is also satisfied for the function f on the closed interval from 0 to 2. Then what does the mean value theorem tell us about what has to be true? if these two hypotheses are satisfied, then it is enough for us to know that there must be at least one x value between a and b. For us, that would be between 0 and 2, such that f prime of c, which of course tells us the slope of a tangent line to the graph of f at x is equal to c, must be equal to this difference quotient, which is, of course, nothing more than what we have here. It is the change in y divided by the change in x, which tells us the slope of the secant line passing through the two endpoints of our interval. That's all that the mean value theorem is, and when you have a function that satisfies the hypotheses, then it is sufficient for us to know that this must be true. The conclusion must be true, that there must be a tangent line to the graph of f on the interval from a to b such that that tangent line will be parallel to the secant line. The mean value theorem, like Rolle's theorem, is what we call an existence theorem. It tells you that something exists, but not necessarily how to find it. How would you find it? Well, you would begin by finding the slope of the secant line, which we found earlier to be 2, and then you would find the derivative of the function f, which we know to be 2x, and you would set the derivative of the function equal to the slope of the secant line and solve for x. And we find that when x is equal to 1, there will be a tangent line with slope 2, making it parallel to the secant line. And if you wanted to write the equation of the tangent line, you would just use the point slope form, and you would write the slope is 2, and x is equal to 1. And what is f of 1? 1 squared is 1, so y is also equal to 1. And this would be the equation of the tangent line that we see here in point slope form. So the example that we just did should have helped you to understand the statement of the mean value theorem. And in our lesson today, we used the vocabulary terms that are listed here.